Welcome dear students to this program. Dear students, earlier we have learnt about algebraic expressions, and in the previous classes you have also come across with the equations. Now, what is the need of equation? In our day-to-day life, we have some problems which can be solved by the equations. Today, we are going to learn from chapter 4, linear equations in two variables. This is part 1. In this part, we will learn about linear equations in one variable, linear equations in two variables, and how to represent a situation in the form of an equation. Let's revisit the following terms. As we have studied earlier in polynomial, here also we deal with algebraic expressions. So let's start with constant. What is constant? As we know, the constant means the value will not change, such as 7, -5, 1/2. That means all the numbers as we use are usually constants. However, in algebraic expressions, we also use A, B, C. These are also used to represent a constant. They are not actually constants, but they can represent some constants in an algebraic expressions, as we studied earlier in polynomials, that the coefficient of x, coefficient of y as a, b, etc. So these letters can be used as constant in some cases. And what is variable? The variable means the value changes, which is able to vary or change. So let's see some examples such as temperature, pressure, and humidity of atmosphere, or price of different commodities, and many more. So in our day-to-day life, we come across with various variables. Let's perform this activity. Open up your copies and pen. Now start with this. What is this? Choose any number between 1 to 9. Okay? Then multiply the number by 3. Then whatever you got, you add the number 6 with that. Now divide this obtained number by 3. Now you subtract the number you chose, the first number which was obtained by you subtract from the obtained number. Now I can guess your answer. Your answer is 2. Okay? Is it? So the answer is 2. Let's see the logic. Understand this logic. What is the logic behind it? Let's take the number be x. If the number is x, then what to do? We have to multiply with it with 3. Then we get 3x. Then what to do? Then add 6 with that value. Then we'll get 3x plus 6. Then divide this value by 3. Then what do we get? 3x divided by 3 gives x, and 6 divided by 3 gives 2. So we obtained x plus 2. Now we have to subtract the chosen number. The chosen number was x, so subtract this x from x plus 2. Then what remains? That is 2. Okay, this is not only true for the numbers between 1 to 9. Just for easy calculation, I gave you to choose from 1 to 9. You can choose any number in place of x. The result will be 2. Okay, so this is a situation in which we can express algebraic expression where for any value of x we always satisfy the equation x plus 2 minus x equal to 2. Is that equation? No, this is a statement. Okay, then what is an equation? An equation is a mathematical statement of equality which is true for specific values of variables. But in the last situation, not the variable was not with a specific value. Any value of x could do that. Okay, now let's see some other situations. X plus 5 is equal to 7 plus x minus 2. If we put the value of x 1, then the left hand side gives 6 and the right hand side also gives 6. If we put the value of x as 0 in left hand side, it gives the value 5, and if we put the value 0 in place of x in right hand side, then again it will give 5. That means this statement is true for both the values of x. So we cannot say this to be an equation. So this situation is not, or this statement is not an equation. Now let's consider another one, that is x plus 2 is equal to 4 plus x minus 2. Is it an equation? Now substitute any value of x, say 4. In left hand side, if we substitute the value of x as 4, it is 4 plus 2, that is 6. But in right hand side, if we substitute the value of x as 4, this gives 4 plus 4, 8, minus 2 is 6. So the value of x as 4 satisfies this statement. Now take another one, very easy, that is x is 0. If we put the value of x as 0, then the left hand side of it gives 2. And now substitute the value of x in right side, it is 4 plus 0, that is 4, minus 2, that again gives 2. That means for the value of x as 0, this statement is also satisfied. So we have multiple value of x for which this statement is satisfied. So we cannot say this to be an equation. Then what is an equation? Now let's consider this case. X plus 1 is equal to 5. For which value of x we get x plus 1 equal to 5? In common language, we can say which number is added to 1 to give 5. Definitely it is 4. Then we can say that for x is equal to 4, x plus 1 is equal to 5. So x plus x is equal to 4 is called the solution of this equation. Let's consider another situation. This is 2y plus 1 is equal to 5. That means which number, twice of which number is added with 1 gives 5? Definitely it is 2. So 2 into 2 gives 4 plus 1 gives 5. That means for the value of y as 2, this situation is satisfied, or this statement is satisfied. So we can say y is equal to 2 to be the solution of 2y plus 1 is equal to 5. Now let's see linear equation in one variable. What is linear equation? Earlier we have studied about linear polynomial. Linear polynomial means the exponent of the variable is 1. Here, the standard form of a linear equation in one variable is represented as ax plus b is equal to 0, where a is not equal to 0 and x is the variable. Then what are a and b? A and b are real numbers. They are constants here. Then equation has only one solution. Then what is the solution? The solution is x is equal to minus b by a, as the term linear refers to the exponent of the variable 1. Okay. Now let's consider what is the solution. The process of finding this unique value. Unique value means it is the only value for which the statement, the algebraic statement is satisfied. Okay. So this is the process of finding the unique value of the variable of an equation is solving the equation. So whenever it is given that solve the statement, that means we have to find the value of the variable, and that value is called the solution or root of the equation in one variable. Okay, let's see an example. 2x plus 3 is equal to 0. This is an equation, a linear equation, and in one variable. What is its solution? Its solution is x is equal to minus 3 by 2. How to solve it? Let's see how we get this x equal to minus 3 by 2. 2x plus 3 is equal to 0. This gives 2x plus 3 minus 3 is equal to 0 minus 3. This gives 2x 3 minus 3 is 0 is equal to minus 3. Now divide both sides by 2. We get, on left side we have 2x by 2 and on right side we have minus 3 by 2. This gives 2 to cancel and x is equal to minus 3 by 2. So this is the solution of this linear equation 2x plus 3 is equal to 0. How to represent it graphically? Graphically we can represent it on a number line like this. As you know, minus 3 by 2 is greater than minus 2 and it is smaller than minus 1, so it lies somewhere between minus 2 and minus 1. And you have already studied about the number line, so the value of minus 3 by 2 is represented on a number line like this, where 0 is said to be origin, and to right of it all the positive numbers and to left of it all the negative numbers. Now see what to remember while solving an equation. While solving an equation, you must always keep the following points in mind. And what are the points? The solution of a linear equation is not affected when we add the same number or subtract the same number, okay, when on the both side of the equation. If we add the same number on both sides, then it will not affect the solution remains same. If we subtract some number, it will remain same, as we noticed in this solution as we performed here. Again, we can also say that the solution will not be affected if any number is multiplied or divided on both the sides of the equation by this same non-zero number. Okay? Why non-zero? because 0, a number cannot be divided by 0. It is undefined. So here it is specifically written, when we consider about the division, the dividend, the divisor must be non-zero number. Okay. Then linear equations in two variables. So how to find the linear equation in two variables? What is that? Let's consider the situation. The situation is like this. In a one-day international cricket match between India and England played in Kotak, two Indian batsmen together scored 206 runs. Express this information in the form of an equation. In this case, we don't know which batsman has done how many scores. Suppose batsman 1 and batsman 2. As we don't know whose score is what, so let the score of the first one be X and the score of the second one be Y. Now this situation says that they together scored 206. That means sum of their score is 206. So we can write here the equation as X plus Y is equal to 206. So here we have two variables. As we don't know what are the value of the score 1 and score 2, so we can take those as variables. So here X and Y are variables. So it is customary to denote the variables in such equations by X and Y. But in some other situations, we can also use other letters for forming an equation. Some examples of linear equations in two variables, we can see that 1.5s plus 2t is equal to 8, p plus 4q is equal to 7, root 2u plus 5v is equal to 9, and 3 is equal to 2x minus 7y. See, in first three cases, we have used the variables other than x and y. And in all those cases, the variables part are on the left side of the equation. Now see, the last equation we can also write in this way, that the constant is to the left and the variable part of the statement is to the right of the equal sign. Okay. So here we have four examples of linear equations. Now let's represent the generalize what is a linear equation is in two variables. So any equation which can be put in the form of ax plus by plus c is equal to 0, where a, b, c are real numbers, a and b are not both zeros. One may be 0, but not both 0, is called a linear equation in two variables. So here we have two variables and the general form is ax plus by plus c equal to 0. Now let's rearrange the equations in this form. Here 1.2s plus 3t is equal to 5. This can be written as 1.2s plus 3t minus 5 is equal to 0. If we compare this with the previous one, that is ax plus by plus c equal to 0, just think s in place of x and t in place of y, then the a is 1.2 here, b is 3 and c is minus 5. Let's consider the second one, that is p plus 4q is equal to 7. Here also just think that in place of x think p and in place of y think q, then we have p plus 4q minus 7 equal to 0. This is in standard form, and coefficient of p is not given here. That means its coefficient is 1. So a is 1, b is 4 and c is minus 7. In root 2u plus 5v is equal to 9, this can be represented by root 2u plus 5v minus 9 equal to 0. Here again you consider a u in place of x and v in place of y. Then here a is root 2, b is 5 and c is minus 9. Now the last one, we can rearrange 3 equal to 2x minus 7y in standard form as 2x minus 7y minus 3. So what is a here? A is 2, b is minus 7 and c is minus 3. Now let's see some other types of equation and how to represent them in general form. X is equal to minus 7. Here we have only one variable. How to represent it in equation of two variables? Now let's see here the coefficient of x is 1. Then what is the coefficient of y? Y is not here. That means its coefficient is 0. So we can write this as 1 into x plus 0 into y plus 7 is equal to 0. So here a is 1, b is 0 and c is 7. In next one, 2y equal to 3. Here x is absent. That means coefficient of x is 0. So we can write 0 into x plus 2y minus 3 equal to 0. That means the a is 0 here, b is 2 here and c is minus 3. Now let's see another example, x equal to 0. Here the coefficient of x is 1. Then what is coefficient of y? As it is absent, so its coefficient is 0. We can write 1 into x plus 0 into y plus 0 equal to 0. So what is a? A is 1. What is b? B is 0 and here c is also 0. Then next comes 5y minus 9. Now here again x is absent, so its coefficient must be 0. So we can write this as 0 into x plus 5 into y plus 9 equal to 0, where a is 0, b is 5 and c is 9. Now let's consider about some situation, how to frame an equation from a situation. Let's see. Consider the following situation, that is a man's monthly income is rupees 52,000. Taking E as expenditure and S as savings, express this information in the form of an equation. As we know, the income is same as the sum of the expenditure and income. Expenditure and savings. Once we have some expenditure, then what remains of our income is the savings. So here we have given E as the expenditure and S as the savings. So sum of these two variables is 52,000. Are they variables? Is expenditure a variable? Yes, if he spends 50,000 and saves 2,000, he can save 45,000 and he can save 7,000. So these two variables can vary. So we can write the situation like this: E plus S is equal to 52,000. Now let's consider another situation. A man purchased 3 pens and 5 pencils with rupees 55, taking cost of pen as X and cost of a pencil as Y. This express this information in the form of an equation. Now, if one pen costs X rupees, as we don't know what is the value of one pen, we can say rupees X. Then cost of 3 pens. What is the cost of 3 pens? Definitely rupees 3x. And cost of one pencil. How much? As we don't know, we can take another variable y. Then we have 5 pencils. So 5 pencils cost rupees 5y. So the sum of all these two items is 55. So we can write the equation 3x plus 5y is equal to 55. So dear students, today we learnt about the linear equation in one variable, linear equation in two variable, general form of the linear equation, and how to find the coefficients of x, y and the constant term. And also we could able to learn the situations, how to express the situations in equations. So this is today's lesson. Thank you.